There is no maximum distance requirement in the National Electrical Code for the service disconnect from the building. However, the service disconnect must be readily accessible and capable of being operated without having to climb over or remove obstacles. This requirement is detailed in the National Electrical Code section 225.30. In the scenario described, a pole-mounted service disconnect would meet this requirement as long as it is accessible from the ground without having to climb over or remove any obstacles. Accessibility is a fundamental principle in electrical installations to ensure safety and ease of maintenance or emergency operations. The National Electrical Code defines readily accessible as being capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to actions such as to use tools, to climb over or remove obstacles, or to resort to portable ladders, and so forth. Considering a pole-mounted service disconnect, several factors should be taken into account to ensure code compliance and safe operation. Firstly, the height of the disconnect should be such that it can be easily reached by a person standing on the ground. Typically, electrical codes specify a maximum height for operating handles of switches and circuit breakers to ensure accessibility for all personnel. Secondly, the area around a pole should be clear of any obstructions such as vegetation, parked vehicles, or stored materials. Clear access pathways are essential for personnel to safely approach and operate the disconnect in case of emergencies or for routine maintenance. Thirdly, the disconnect enclosure itself should be weatherproof and suitable for outdoor use to protect the electrical components from environmental elements such as rain, snow, and sunlight. The enclosure should also be securely mounted on the pole to prevent movement or damage due to wind or other external forces. When feeding power from the pole-mounted service disconnect to a building located 200 feet away, several additional considerations come into play. Firstly, the feeder conductors must be properly sized to carry the intended load and to minimize voltage drop over the 200-foot distance. Voltage drop occurs when the voltage at the load end of the feeder is lower than the voltage of the source due to the impedance of the conductors. Excessive voltage drop can cause equipment malfunction, reduced efficiency, and potential safety hazards. To calculate the appropriate conductor size, one must consider the total load in amps, the length of the feeder in feet, the voltage of the system, and the allowable voltage drop percentage. The National Electrical Code provides tables and formulas for calculating voltage drop and determining the minimum conductor size required. Secondly, overcurrent protection must be provided at both the supply and load ends of the feeder to protect the conductors from overloads and short circuits. The overcurrent protection device, such as the circuit breaker or fuse, should be sized according to the ampacity of the conductors and the requirements of the connected equipment. The National Electrical Code specifies the rules for overcurrent protection in Article 240. Thirdly, a grounding electrode system must be installed at the building to provide a low impedance path for fault current to return to the source. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal water pipes connected to the building's grounding busbar. The National Electrical Code requires that the grounding electrode system be installed in accordance with Article 250. The grounding electrode conductor, which connects the grounding busbar to the grounding electrode, must be sized according to the size of the service entrance conductors. In the scenario described, the building is treated as a sub-panel with an isolated neutral, a 4-wire system, and a grounding electrode system. This configuration is commonly used when feeding power from a separate building or structure to ensure proper grounding and bonding. An isolated neutral means that the neutral conductor is not bonded to the grounding conductor at the sub-panel. This prevents neutral current from flowing through the grounding conductors, which can cause nuisance tripping of ground fault circuit interrupters and other electrical problems. A 4-wire system consists of 2 hot conductors, a neutral conductor, and a grounding conductor. The grounding conductor provides a path for fault current to return to the source, while the neutral conductor provides a return path for normal load current. The grounding electrode system provides a low impedance path for fault current to earth, which helps to protect people and equipment from electrical shock. When installing a subpanel with an isolated neutral, it is important to ensure that the grounding conductor is properly connected to the building's grounding electrode system. The grounding conductor should be sized according to the size of the feeder conductors and should be run in the same raceway or cable as the feeder conductors. It is also important to ensure that the neutral conductor is properly isolated from the subpole enclosure and other grounded metal parts. The neutral conductor should only be connected to the neutral busbar in the subpanel. Some additional considerations when dealing with electrical installations include firstly, compliance with local codes and regulations. Electrical codes and regulations may vary depending on the jurisdiction. It is important to consult with local authorities to ensure that the installation complies with all applicable requirements. Secondly, use of qualified personnel. Electrical work should only be performed by qualified and licensed electricians who have the knowledge and experience to safely and correctly install and maintain electrical systems. Thirdly, proper documentation. Accurate and up-to-date documentation of the electrical installation, including wiring diagrams, panel schedules, and equipment specifications, is essential for future maintenance and troubleshooting.